You ever get that knot in your stomach right before a big decision when you just don't know what's going to happen? Well, that's not some personal flaw. Turns out, it's a fundamental feature of your brain. Today, we're going to dive into exactly why our minds are so powerfully wired to hate, and I mean hate, uncertainty.
We've all heard this saying a million times, right? And it perfectly captures this subconscious bias that shapes our decisions pretty much every single day. We will actively choose a familiar, maybe even a bad, situation over a mysterious one, all because we just crave predictability. And there's actually a technical name for this. It's called ambiguity aversion. It's our built-in preference for known risks, where we actually know the odds, over unknown risks, where the probabilities are a complete black box. We'll always favor the devil we can calculate over the one we can't even begin to measure. Now, this isn't just some minor quirk. It's a really powerful force in our lives. So the question is, why? Why does our brain have this built-in alarm system that goes off whenever things get ambiguous? What's really going on under the hood that makes us cling so tightly to certainty? Let's unpack that. All right, here's our game plan. First, we're going to see this bias in action with a classic experiment. Then, we'll get really clear on the difference between risk and ambiguity. After that, we'll dive into the neuroscience to see where this all starts, check out its impact in the real world, and wrap up with a puzzle that scientists are, believe it or not, still trying to solve. So let's start with a famous thought experiment that just perfectly illustrates this whole aversion to the unknown. It's called the Ellsberg paradox, and it really gets right to the heart of what we're talking about. Okay, so imagine you've got two big jars, or urns. Urn A is super simple. It has exactly 50 red balls and 50 blue balls. The odds are clean 50-50. No mystery there. But Urn B is a total wild card. It also has 100 balls, but the mix of red and blue, completely unknown. It could be 99 red and 1 blue, or the other way around. You just don't know. So here's the choice. You win $100 if you correctly guess the color of the ball you draw. Which urn do you choose to bet on? Go ahead, pick one. Well, study after study shows that people overwhelmingly bet on Urn A. Even though Urn B could have odds that are massively in their favor, they prefer the certainty of that 50-50 split. And that choice, right there, highlights a really critical distinction. See, we often use the words risk and ambiguity like they're the same thing. But to our brains, they are worlds apart. Let's break that down. So here's the key difference. Risk aversion is when you prefer a safer bet even when you know all the probabilities. But ambiguity aversion, which is what we just saw with the urns, is a whole other beast. It's choosing the known risk of Urn A over the unknown risk of Urn B. We're not just avoiding risk, we are actively running away from any situation where the risk is impossible to even calculate. Okay, so we know we have this bias, but the real multi-million-dollar question is, why? Is this something we learn, or is it hardwired into us from the moment we're born? Well, the latest science is pointing to our earliest, most vulnerable moments. Yeah, a lot of new research suggests that our aversion to ambiguity is actually shaped by our first experiences in life. When a child faces really profound adversity, we're talking things like neglect or just chronic instability, their developing brain gets flooded with the stress of extreme uncertainty. And that experience, it can leave a permanent mark. In fact, research shows that early life stress can physically change how key parts of the brain develop. And we're talking about the prefrontal cortex, the amygdala, the hippocampus, and the corpus callosum. Each one of these plays a super important role in how we see and react to the world around us. So to understand what's at stake, think of them like this. The prefrontal cortex is kind of like the brain's CEO handling all the planning and self-control. The amygdala, that's your threat detector, the emotional alarm bell. The hippocampus is the librarian, managing your memories and helping regulate stress. And the corpus callosum is the super fast internet cable connecting the two halves of your brain. Early adversity can mess with every single one of them. And it's not just the brain's hardware. Profound uncertainty in childhood can also break the body's central stress thermostat. This system is called the HPA axis, and it's basically what controls our entire fight or flight response. And this kicks off a major chain reaction. The chronic stress from early adversity throws that HPA axis totally out of whack. This can lead to constantly high levels of the stress hormone cortisol, which is basically poison for a developing brain. The end result is a completely rewired stress response, which can create a lifelong hypersensitivity to uncertainty. The brain learns a really dangerous lesson early on. The unknown isn't an opportunity, it's a threat. period.
So we've got this neurological basis, but how does this aversion to ambiguity actually pop up in the real world? Well, it turns out its fingerprints are all over the place, from the global economy all the way down to the little strategic choices we make every day.
I mean, this aversion has a massive impact. It makes stock markets go haywire when the future is unclear. It's the whole reason we buy insurance, not just to manage risk, but to completely eliminate the ambiguity of a potential disaster. It can even make people decide not to vote if they're unsure about the candidates. And it totally changes how we play strategic games. Just take a look at this experiment. So players had to coordinate their choices to get the biggest payout. But one player was given this extra option, a safe choice. It offered a small but guaranteed win. Now, logically, it wasn't the best move, but it had one huge thing going for it. It completely removed the ambiguity of having to guess what the other player was going to do. And the result was absolutely fascinating. Players consistently chose that safe option, even when coordinating for a much riskier move could have paid off way more. Our desire to avoid the unknown is so strong that it literally overrides what we'd call rational decision-making. We will actually pay a price just to avoid ambiguity.
So it's pretty clear that our relationship with uncertainty is, well, it's complicated. It's rooted deep in our development. It has powerful real-world effects, and for neuroscientists, it's still one of the great enduring puzzles of the human mind.
So here's the big takeaway from all this. Our preference for the known over the unknown isn't just a quirky part of our personality. It's a fundamental feature of how our brains work, and it seems to be forged in our very first encounters with stress and uncertainty. And the research is far from over. Right now, scientists are trying to crack the brain's neural code for uncertainty itself. They're trying to figure out how our neurons can even represent something as abstract as a belief or our level of confidence in it. I mean, this is the absolute frontier of neuroscience. And all of this brings us to one final thought. Now that you know about this powerful hidden force, this instinctive hatred for ambiguity, how might it be shaping your decisions? In your career, in your relationships, with your money. And if you zoom out, how is it shaping our whole society? It's a question that's definitely worth pondering.